Okay, let us start. Okay, now you have a little bit idea about the stress strain curve of concrete and mild steel and HOSD bar. Okay, uh, you just tell me what is the difference between the stress strain curve of mild steel and stress strain curve of HOSD bar. Anyone can tell me. What is the main difference between stress strain curve of mild steel and stress strain curve of HOSD bar?
Sir, for mild steel, the curve is straight line, inclined like 45-degree angle, and for other one, it's uh, straight line side by side horizontally.
No, you can see uh, this is same for mild steel and HOSD bar. Okay.
Oh,
Okay, so this is not the difference. Actual difference is the stress strain curve have a for mild steel it has a specific yield point. Okay, but for HOSD bar there is no specific yield point. At this particular position there is a curve only, no specific yield point is there. Okay, this is the main difference, and you have to keep in mind that this is very important. This is important phenomena. Okay, now you know the bending stress and shear stress. No, did you watch the last video that I have posted?
yes, sir.
Okay, tell me what is the bending stress? What is the bending stress? Hello, what is the bending stress? Ankush?
Hello, sir. Bending
Sir,
stress is a more specific type of normal stress.
Specific type of normal. No, bending stress. You can say that. Bending stress is the longitudinal or normal stress produced by bending. Okay, nothing else.
Yes, sir.
Now you know the stress strain curve of all those material, and you know what is bending stress, what is shear stress, what is bending moment. You know. Okay. Now you have to synchronize all those things. Okay. Now first of all, consider.
can I say?
Hello. Hello. Who said that? Okay.
Hello, sir.
First of all, you consider a simply supported beam. Okay. And we are applying a point load at the
Sir, I can say what is bending stress.
hello. Hello. Who said that? Please repeat that. Hello.
Sir, Srimu Koyal.
Yes. Tell me. হ্যালো,
স্যার আমি জাস্ট জয়েন করলাম।
না না, কেউ একজন কি বলতে চাইছিল। ওকে, now if you don't know what is bending stress and what is shear stress, you can go through the last video that I have posted here in the group. Okay, you can understand all those things. Now consider a simply supported beam, and we are applying a point load at the midpoint of this beam. So you tell me the shape of the bending moment diagram. What is the shape of the bending moment diagram?
Triangle.
Triangle is, sorry, this is triangle. Now, can you please tell me what is the meaning of this diagram? What is the meaning? What does it indicate? What is the actual meaning of this diagram, of this bending moment diagram?
So at the maximum point, at the peak point, the bending moment is maximum.
Yes, at the peak point, bending moment is maximum. That we can show in this diagram. Okay. And anything else?
Sir, the midpoint is the bending moment, maximum bending moment point.
Yes, midpoint is the maximum.
The
bending
midpoint.
moment. Yes. So you can say, but actual meaning of this diagram is that the diagram saying you, if I consider a particular cross section at any position of the beam, okay, suppose this is the cross section, and if I consider this cross section at any point of the beam, then the bending moment value will be this. Okay, this is the value of the bending moment. Now, if I consider a section here, this is the bending moment. Okay, if I consider section here, this is the bending moment. Okay, the diagram is saying that each and bending moment value of each and every cross section. Please keep in mind, the diagram is saying that the bending moment value of each and every section this beam throughout the length. Okay, now when we are going to design this beam, okay, what we are actually doing, we assume a particular cross section, okay, and we design that beam against that bending moment in such a fashion that the beam can resist this amount of bending moment. Okay, now suppose this is the maximum bending moment. Okay, and if you consider this bending moment, then you can find the cross section should be the dimension of the cross section should be the maximum for this section. That means to resist this maximum bending moment, suppose this is the cross section, and if I consider this beam, this cross section, then this is the value of the bending moment. Suppose you design against this bending moment, you can find, suppose this is the cross section. Okay, so this is the reinforcement. Now if I consider this section, then the bending moment is very small. Okay, now if you design against this amount of bending moment, you can find there the cross section is also very less. Okay,
স্যার শো করছে না স্যার, যেটা যেটা করাচ্ছেন
শো করছে না?
না স্যার।
না স্যার, কিছুই শো করছে না।
স্যার শো করছে স্যার।
হ্যাঁ স্যার শো করছে।
তোমরা
স্যার হাই স্পিড হলে আপনার কথার সাথে ভিডিও মিলছে, না হলে মিলছে না, ওটা ভিডিও লেটে আসছে, আপনার কথা তাড়াতাড়ি শোনা যাচ্ছে।
ওকে ওকে, তো
না স্যার দূরে ঠিকঠাক আছে।
স্যার আমাদের কিছুই শো করছে না।
কিছুই শো করছে না, কোনো রকম ভিডিও
স্যারের দুখানা অ্যাকাউন্ট আছে, তাই জন্য ওরা স্যার একটা অ্যাকাউন্ট দেখছে।
নাম্বার 1
আর যে
তোরা অন্য অ্যাকাউন্ট দেখছিস ভাই।
তোমাদের একটু গাইড করছি তোমাদের। দেখো এখানে যদি পিপলে যাও তাহলে দেখতে পাবে যে তোমরা আমার দুটো অ্যাকাউন্ট আছে। ওকে, এখানে সি টিউটোরিয়াল একটা অ্যাকাউন্ট, সাইডে দেখো দেখা যাচ্ছে হয়তো, আর একটা আছে একটু নিচের দিকে, মেবি কোথায় গেল,
স্যার ওপরে ছিল দেখুন, ওপরে আছে, ওই তো নিচে নিচে।
দেখো
হ্যাঁ,
ব্র্যাকেটে লেখা আছে ইওর প্রেজেন্টেশন।
মানে পিন দিলে হবে, পিন করতে হবে।
যদি পিন করো তাহলে এই
হবে।
স্ক্রিনটা দেখা যাবে। ওকে,
হ্যাঁ হ্যাঁ
মনে রাখবে যে হোস্ট করছে তার একটা অ্যাকাউন্ট, আর সে যখন প্রেজেন্ট করছে তার জন্য আলাদা একটা অ্যাকাউন্ট ক্রিয়েট হচ্ছে এখানে। ওকে, তো তুমি যখন প্রেজেন্টেশনের অ্যাকাউন্টটা পিন করবে তখনই তুমি এটা দেখতে পাবে। আদারওয়াইজ
প্রেজেন্টেশনটা আসছে না স্যার।
প্রেজেন্টেশনের অ্যাকাউন্টে পিন করো।
স্যার আসছে না স্যার। শো করছে না ওটা।
শো করছে না, সে কি অনেকের তো করছে। প্রেজেন্ট তুমি একবার এটা লেট করে একবার জয়েন করো, করে প্রেজেন্টেশনের অ্যাকাউন্টটা পিন করো।
না স্যার, ব্র্যাকেটে কোনো রকম প্রেজেন্টেশন লেখা নেই, দুটোতেই ওই সি টিউটোরিয়াল লেখা আছে শুধু।
ও আচ্ছা আচ্ছা, আমার এখানে তো দুটোই দেখা যাচ্ছে। যাই হোক, তো তুমি যে কোনো একটাতে ট্রায়াল করে দেখতে হবে, দুটোতেই কোনটাতে হবে আর কি।
হ্যাঁ স্যার পেয়েছি।
নয়তো আর কোনো অপশন নেই। ওকে, now what I have told you that if I consider a particular cross section, and suppose this is the cross section and you can see the maximum bending moment is this. Now if you design against this maximum bending moment, you can find the cross section, the dimension of this beam will be very high. Suppose the depth is very high. Okay, the reinforcement is also very clumsy, you can see. But when you design for this particular cross section, that is bending moment is less than the maximum one, then you can find the cross section maybe it will be less. Okay, so this is the reinforcement, and if you consider this cross section, the bending moment is very low. For this case, the cross section will be also less. Okay, now you tell me, if I consider each and every cross section, there is infinite number of cross section. Okay, if I consider each and every cross section and if I design against that bending moment of this particular cross section, then there is the variation of the depth of the beam. Okay, if we consider width of the beam is constant, then there should be a variation of the depth. Okay, now if you have seen any kind of beam except cantilever, say like that, suppose this is the width of the beam. Okay, and say this is the depth of the beam. Have you ever seen like that?
স্যার শো করছে না।
কে কে দেখতে পাচ্ছ? সবাই কাউকেই শো করছে না নাকি?
না স্যার, আমরা দেখতে পাচ্ছি।
আমরা
দেখতে পাচ্ছি।
করছে না।
আরে ফারেস, ওখানে দেখ দুটো সি টিউটোরিয়াল আছে।
দুটো আছে, একটা প্রেস করলে
দেখাচ্ছে না, দুটো দেখাচ্ছে না।
স্ক্রল করে দেখো,
দুটো
স্ক্রল করে দেখো।
দেখো, সবাই কিন্তু অনেকেই কিন্তু পাচ্ছে, কিন্তু মেবি কারোর
করলে পাবে।
প্রবলেম হচ্ছে। তোমরা একবার ফোন রিস্টার্ট করে দেখতে পারো, অথবা গুগল মিটটা আনইনস্টল করে একবার ইনস্টল করে দেখতে পারো। ওকে, তাছাড়া কিন্তু পসিবল। আমার এখানে কিছু স্টুডেন্ট বলছে সবই দেখতে পাচ্ছে, তো আমি কি করব বলো, কিছু করার নেই। Okay, now you tell me, did you send this kind of beam? Suppose this is the width. Okay, this is the B width, and this is the maximum depth for this case. Okay, and for this is the minimum depth, and this is the minimum depth. Okay, you can see all structures, all beam or all columns are purely rectangular. Okay, so this is the width of the beam, this is the depth of the beam. Okay, that means throughout the length of the beam, the depth is constant, and theoretically you can see that the depth of the beam is varying. Okay, now how it is possible? because we are considering actually the maximum bending moment. That means suppose this is the midpoint of the beam, okay, and this section will resist this maximum amount of bending moment, okay. Now for this section, for this section, the section I have designed and I have applied is this, but the bending moment is less than the capacity, okay. But if I construct with this type of cross section of the beam, this is very difficult. That's why for our simplicity, what we have done, we generally construct the depth of the beam is throughout the length of the beam, the depth and width of the beam is same, okay. For our simplicity, we construct this type of particular rectangular beam. Now what I have done actually, I have considered only the maximum bending moment. We have considered only the maximum bending moment. That means we can say that for our case, suppose this is the simply supported beam and this is the bending moment diagram triangular, but we consider only this maximum bending moment, okay. The maximum bending moment value is this, and for any other section we just neglect the another bending moment value. You got my point? We just neglect the another bending moment value. We are neglecting all those value we are neglecting, okay. That means there is we just consider this highest amount of bending moment. So you can say that the bending moment is actually occurring at the midpoint, okay, actually occurring at the midpoint. Now if this is a clockwise bending moment, how we can produce a clockwise bending moment? How we can produce a clockwise bending moment? Suppose, let me create a new page. Suppose this is a beam and this is the support. We create a mechanism that is, we have attached a very rigid small amount of very rigid bar with this beam, okay, and welded at this junction. This is welded connection, okay. Now if I apply a force at this point and a force at this point, the force is amount of force is F, suppose, okay, and the distance between these two force is suppose X, okay. Now we can say that the beam will bend like, if it is a clockwise moment, it is a couple of force, it is a clockwise moment, the beam will bend like that, okay, and this is the rigid bar, okay. That means at the midpoint the moment is creating, okay. Now to keep this body in equilibrium, what I can do? To keep this body in equilibrium, we can apply another couple of force in anti-clockwise direction, okay. We can apply another force in anti-clockwise direction. So that means this F into X, this is the bending moment. F coupled into X. This is the bending moment. Okay. So this is the bending moment. F into X. Now, if I consider that there is another anticlockwise moment, couple of force or moment is there, then we can say that this beam will be keep in equilibrium position. So how we can apply another anticlockwise moment? Actually, it is not applying by us, it is actually applying by the material itself. The material itself will apply this type of couple of force, and it will resist the external bending moment. You got my point? Suppose
Yes, sir.
we have the beam like this, and if we apply a point load, the beam will bend, and you can see the compression will happen at the topmost fiber, and at the tension will happen at the bottommost fiber. Okay. And what is actually happening at the compression zone? Material is applying a force, and the tension zone, material is applying a force, and though these two forces are same in magnitude are same, okay, and the distance is x. So in the compression zone, the applying forces we can denote by C, and in the tension zone, that applying force we can denote by T. So this can be C. We can say that this is T, it's C, and this is T. Okay. Now the actual moment, which is I should say the anti-moment, okay, that is resist the applied moment. This moment created by the beam will be, say, equal C multiplied by X, okay, or we can say moment equals T multiplied by X, okay. So you can see this C or T is nothing but F, and the distance is X, okay. Now you can say our applied bending moment developed by the external bending moment. We have applied a load here W, okay, and you can see the bending moment diagram is a triangular one, and this value is the maximum bending moment M, okay. So this maximum bending moment, if I equal this maximum bending moment equal to the moment creating by the material itself, that is C into X, or we can say if this bending moment is equal to T into X, we can say that the beam is safe, okay. So that means this beam can resist this load W, okay. This beam can resist this amount of load W. So what I have done, I have actually equating the external bending moment equal to the bending moment created by the material itself, okay. So at the tension zone, a compression force will be created, and at the compression zone, compression force will be created. At the tension zone, tension force will be created, and the distance between two force is nothing but x. And another point you can say, that second point you can notice that always C is equal to T. Okay, always C is equal to T. That means compression is equal to tension. Now, how we can explain all those things? Now you know that the bending moment equals C into x or T into x, and C is nothing but compression, T is nothing but tension. But how it is developed in the material? You know the bending stress. Bending stress is nothing but longitudinal stress. If this is the neutral axis of this beam after bending, then above the neutral axis the zone is the compression zone, and you can find that this is the bending stress. Okay, this is the bending stress diagram. That means at the topmost fiber the stress is maximum, so this length indicates the maximum stress. Say suppose sigma c. Okay, maximum stress. Sigma indicates the stress and c indicates the compression zone. Okay, and at the bottommost fiber tension is the maximum, so this length indicates the tensile stress, sigma t. Okay, now we can say that if this maximum compressive stress will exceed, if this maximum compressive stress will exceed the permissible stress of this material, suppose this is the stress strain curve of concrete, we are neglecting the curve portion. Okay, that's why this is the dotted portion. Okay, now we are considering the only the elastic limit, up to the elastic limit. This is the tensile stress strain curve for concrete. Okay, now we can say that the topmost fiber is under highest compressive stress. So if this value of the sigma c will exceed this amount, we can say that the material will fail, because concrete can resist only this amount of stress. Okay, this amount of stress. And suppose this is the stress strain curve of mild steel. Okay, now we are considering suppose this amount of stress. Now we can say that if sigma t will, the value of sigma t will exceed this value of sigma t will exceed this value, then the material, that is the reinforcement, will fail. Okay, so you can understand that why the stress strain curve is important to understand the concept of the RCC design. What we have done, we are actually considering the particular value of stress that is given by our IS code. Okay, this is permissible stress in working stress method, and you cannot go beyond that limit. You cannot go beyond that stress. Okay, you have to strict into this amount of stress. That means if sigma c exceed this value for concrete, then we can say that the material will fail, and if sigma t will exceed this value, we can say that material will fail. Now, how we can correlate between the force and the stress, C and sigma c, or T and sigma t? How we can, what is the relation between T and sigma t in tension zone, or C and sigma c in compression zone? What is the relation? You know that the stress, the force, I should say, the force is equal to stress multiplied by area. Okay, the force equals the stress multiplied by area. So if I consider that the area of the concrete in the compression zone is AC. Okay, if the area of the concrete in compression zone is AC, and if I consider from the stress bending stress diagram the maximum stress sigma c, we can say that this is nothing but C. We can say that this is nothing but C, because C is the force. Okay, this is the C. The C is the force. Force is equal to nothing but stress into area. Okay, so what we are doing, we are actually equating the we are actually multiplied the stress with area, that is actually force, and again we multiplied the force into the x distance. The x distance is, this is, if this is the compression, this is the tension, suppose this is T, suppose this is C. Now the distance between two force is x. Distance between two force is x. Okay, this is T and this is C, and the distance between two force is x. Now C into x is equal to our applied bending moment. Okay, you can find a relation between the bending moment and the area. Okay, between the bending moment and the area, because ultimately we have to calculate the area. Okay, and area is nothing but the multiplication of two dimension, that is, one is depth, another is width. Suppose B. Okay, one is depth B, D, and that is width B. Okay, now in the previous class I have said you that the basic requirement to design a structure is nothing but the find out the dimension. Okay, when we are going to design a beam, we are actually, what we are actually doing, we are actually calculate how much B should be provided, how much D should be provided. Okay, this is the actually nothing but the area of the cross-sectional area of the beam, and this B and D we can calculate from the area. Okay, and this area, if we multiply it with the stress, that is permissible stress, always it will be provided by your IS code. Okay, IS code always provide you this value, sigma c or sigma t value. Okay, you cannot choose randomly. So there is some restriction, later on we will show. Okay, so if I multiplied area with sigma c, we can get the compressive force C. Okay, and this compressive force, if we multiplied with the x, that is the distance between two force C and T, because C always equal to T. Please keep in mind, C always equal to T. Okay, so if we multiply it C and x, then we can get a moment. We can get a moment m, and that moment should be equal or maximum than the applied bending moment. Okay, so generally we consider this bending moment should be equal to the applied bending moment. That we can say that the beam is safe. Now, if you see the another point of view, that means from tension side, so our external internal force is one is C, another is T. Okay, and if we can say that bending, if this beam is in a safe condition, that means the minimum condition should be bending moment equals to C into x. This distance is x, C into x or T into x. Okay, now you know the bending stress strain curve of mild steel, and suppose IS code is providing you the value of sigma T, that means stress of mild steel or HSD, whatever it is. So value of stress of steel is provided by IS code. Okay, now you can say that T is coming from sigma T multiplied by area of steel. Okay, so T is equal to sigma T multiplied by area of steel, and you know that when we are going to design a beam, we have to calculate width of the beam, we have to calculate depth of the beam, and area of reinforcement. That means we denote the area of reinforcement by AST. Okay, AST. Okay, so this is actually nothing but AST. Okay, so AST we can find by multiplying the sigma T with AST and equating this with T. T is nothing but tensile force, and if I multiply the tensile force with the x, then we can get and if we equal with this bending moment, we can get the value of AST. This is actually the design what we are doing actually in working stress method or limb stress method, whatever it is. The all for both method, the fundamental principle is this. Okay. Now, in brief, we can say that the bending moment, the applied bending moment created by the external load equals to compressive force into x, or we can say this is sigma c, that means compressive stress into concrete into area of concrete into x. Okay, so bending moment is equal to compressive stress into area of bending moment is equal to compressive stress into area of concrete into x. This x is called actually lever arm. This x is actually called a lever arm. Okay, this is called lever arm. Or we can say bending moment equals to T multiplied by x, that means lever arm, and equals to sigma T multiplied by AST multiplied by lever arm, nothing else. Okay, up to this, is it clear to you? Up to this?
স্যার লাস্টে লিভার আর্ম আরেকবার বলুন।
লাস্টে কোনটা বলো?
লিভার আর্মটা।
Lever arm. Okay, lever arm is nothing but the distance between two force. Okay, again I am showing you. Suppose this is the depth of the beam and so this is the neutral axis. Okay, so this is the compressive zone and this is the tension zone. Okay, now at this zone you can find that at the topmost fiber will be subjected to maximum compressive stress, and when we go to the neutral axis, then it will automatically decrease again and again. It will automatically decrease, and at neutral axis it will be 0. Okay, and at the tension zone, the maximum tensile stress will be this, and again it will decrease up to 0 at neutral axis. Okay, now if you draw a line, then you can find that this is the bending stress diagram. Okay, now this bending stress diagram has two kind of stress. One is compressive stress at the above the neutral axis, and the tensile stress below the neutral axis. And the shape of this compressive stress is nothing but triangular. Please keep in mind, the shape of this compressive stress is nothing but triangular. So can we say that there is only one compressive stress, acting as a resultant of all those stress? Can we say that? All those stress, only one compressive stress is acting at the compression zone as a resultant of all those stress. Yes, we can say, and we can find the magnitude of stress, and we can find the position of stress also. Please keep in mind, we can find the position of stress also. Could anyone tell me what is the position of the stress from say this topmost fiber? Could anyone tell me? That means what should be the distance? What should be the distance from topmost fiber?
3/7, sir.
3/7.
Three by four.
Oh.
3 by, you see, suppose this distance is d, okay, suppose this distance is d, and for our simplicity we consider this distance as a half of d, okay. So okay, let us forget about d, it will be very difficult. You just assume this distance of topmost fiber from the neutral axis is, suppose it is s, suppose it is s, okay. Now this is the triangle, and this resultant force will act through the CG of this triangle, nothing else, okay. This is the CG of this triangle, so you have to find out the CG of this triangle. So actually my question was that what is the distance between the topmost fiber and the CG, okay. The topmost fiber and CG distance will be, this will be how much, 1/3 of s, okay, 1/3 of s. This is 1/3 of s, nothing else, okay. And again for this case, if say this is T, then there is a compressive stress, okay, and sorry, this distance again 1/3 of T, okay. Now in the last video I have told you that model I have shown that is exactly not correct, that is wrong, and now I am going to tell you why it is wrong. You just remember when you solve the analysis of the structure analysis, that means when you calculate the bending moment and shear force, okay, then you find you can remember that the beam is like this. This is the beam, and it has only one dimension, that is length, okay, that is only length. That means this is one dimensional object, and when you calculate the bending stress, this is the bending stress, you know now, this is the bending stress, this is compression, this is tension, okay. And this diagram is a two-dimensional diagram. That means it has a y and it has a x-axis. It has a y-axis, it has a x-axis, okay. Say suppose this is y-axis, this is x-axis, and if you draw the bending stress diagram, suppose this will be the bending stress diagram, okay. That means in negative y or x-axis we consider the compression zone, at the positive x we consider the tension zone, okay. So this diagram is the two-dimensional diagram. That means for to calculating the bending stress and to draw the bending stress diagram, we have to assume the beam as a two-dimensional element. Otherwise, we cannot calculate or we cannot draw the bending stress diagram. Okay, that's why we always, you can find in your textbook this type of figure. This figure we are actually assuming to draw the bending stress diagram because there is a depth with length. To calculate the bending moment diagram, there is only length, and to calculate the bending stress diagram, there is depth with length, depth and length. Okay, depth and length is there. Okay, so what does it mean? It is a two-dimensional element. That means it is a lamina. That means it is a plate-like element. If you draw a 3D diagram of this two-dimensional element, you can see that, suppose, sorry, this is the beam, that is, and suppose, 1 minute. Suppose this is the thickness. That means the thickness is very negligible. Okay, this is the thickness. That means this is a lamina. Okay, thickness is very negligible. You don't consider, we don't consider thickness of this beam. That means we don't consider width of this beam. Okay, to calculate the bending stress diagram. Okay, so this is D and this is L. Okay, and for this case B is not there. Okay, B is absolutely invalid for this case. Now you find the bending stress diagram. Okay, now if I say that the bending stress diagram of the beam is actually of a two-dimensional beam, then suppose this is the beam. I am trying to draw this two-dimensional lamina or beam in 3D model like that. Suppose this is one lamina. Okay, so for this case there should be one bending stress diagram. Suppose there is another lamina behind this first one. So for this case there should be another bending stress diagram. Suppose there is another lamina, and for this lamina there is another bending stress diagram. Okay, now if you attach all those lamina, okay, say there is n number of lamina, and if you attach all those lamina, you can get a particular three-dimensional actual real life beam. Okay, actual real life beam. So there is infinite number of lamina, and for this infinite number of lamina there is infinite number of bending stress diagram. And if you
স্যার সাড়ে বারোটা বেজে গেছে স্যার।
আরে বাবা একটু ওয়েট করো,
ঠিক আছে
2-5 মিনিট একটু লেট হলে কিছু হবে না।
বারোটা বেজে গেছে।
Okay, now for infinite number of lamina, if you attach all those lamina, you can get a 3-dimensional bending stress. A 3-dimensional bending stress like this. Okay, you got my point. So now if you calculate the total volume of this compressive block, total volume, I say again total volume, not total area, because why I said volume, because this is a 3-dimensional figure. Okay, so if you calculate total volume of this block, then you will get C. Okay, and if you calculate total volume of this block, you will get actual T. Okay, and this distance between C and T, this vertical distance is actually X, that is lever arm. Okay, so this is C, this is T, and this is lever arm. Okay, next day we shall discuss how we can calculate the total volume of this compressive stress block, and how we can calculate total volume of this tensile stress block, and the working stress method will start from the next day.
স্যার নেক্সট ডে স্যার 10 AM।
হ্যাঁ কি বলছো?
10 AM কালকে সকাল 10টায় আছে।
হ্যাঁ ঠিক আছে, no problem.
ঠিক আছে।
Okay, now you tell me if there are any problem to understand all those things. You just tell me. Is there any problem? Any doubt? No doubt.
নো স্যার।
Okay, anyone else? Ankush, any doubt? শুভজ্যোতি পড়ে
না স্যার, আমি ভিডিওটা দেখে স্যার পরে যদি আবার কখনো মনে হয় তখন জিজ্ঞাসা করবো।
ওকে রাখা,
আমি স্যার ভিডিওটা আবার দেখবো প্রথম থেকে।
ঠিক
নো
আছে।
স্যার ঠিক আছে।
ওকে, তোমরা তাহলে বুঝতে পেরেছো অ্যাকচুয়ালি আমরা আরসিসি ডিজাইনে কি করছি? বোঝা গেছে? রূপম মিত্র, পূজন শিকদার, অনিমেষ কুমার, অনিশ কুমার,
ইয়েস স্যার।
ওকে বোঝা গেছে তো? আমরা ডিজাইনে কি
Yes, sir.
করছি? আমরা বেন্ডিং মোমেন্টটাকে ইকুয়াল করছি আমরা কার সাথে? ইন্টারনাল যে বেন্ডিং মোমেন্ট রেজিস্টিং ক্যাপাসিটি তৈরি হচ্ছে তার সাথে। ওকে, আর সেটা অ্যাকচুয়ালি কিভাবে করছি? কম্প্রেশন ইনটু লিভার আর্ম অর টেনশন ইনটু লিভার আর্ম। বুঝা গেল? তো এই কম্প্রেশন আর টেনশন এটা কিভাবে ক্যালকুলেট করছি? স্ট্রেস থেকে। স্ট্রেস ইনটু এরিয়া ইজ ইকুয়াল টু কম্প্রেশন, স্ট্রেস ইনটু এরিয়া ইজ ইকুয়াল টু টেনশন। এই সিম্পল ব্যাপার। ওকে, তো তোমরা নেক্সট দিন আমরা এগুলো ডিসকাস করবো। ওকে, okay, today I stop here. Okay, next, from the next class we shall start working stress method. Okay, now you can leave it.
থ্যাংক ইউ স্যার।
লিভ নাও।
Okay, 1 minute. I
Okay,
just
sir. One.
I just take attendance. Okay. Abdul Rakib Sef, Abir De, Anish Kumar, Akash Sen, Anamul Alam, Animesh Mondol, Arindam Mondol, Disha De, Manav Das, Mouli, Naimul Islam,
Present, sir.
okay, Premangshu Naskar, Raka Das, Ranit Das, Rose Devnath. Rose Devnath. Who is Rose Devnath? Your good name is Rose Devnath? Rose? Hello? Who is Rose Devnath?
না স্যার তানভি দেবনাথ
Tanvi. You just change your name, okay, here. Okay. Otherwise, it is difficult, very difficult to mark, to track the student. Okay. You just change your name. Rupam Mitra, Sangita Devnath, Sayan Dev, Saurabh Bepari, Saurabh Roy, Shaufik Mondol,
sir.
Shubhajit Poel, Tanmay Mondol. Okay. Only 24 student. Okay. Okay, you can leave the meeting. Okay. Now, thank you.
স্যার 21 আর 32 ছিল বেরিয়ে গেছে অর্ধেক বেরিয়ে গেছে আপনার কাউন্টিং এর আগে।
না, কাউন্টিং এর আগে বেরিয়ে গেলে হবে না, আমি লাস্টে অ্যাটেন্ডেন্সটা নেব, ওদেরকে সবাইকে বলে দিও, ঠিক আছে?
ঠিক আছে স্যার বলে দেবো।
পরের দিন থেকে যেন এটাকে অ্যাটেন্ডেন্সটা ম্যানুয়ালি আমি আমাদের এখানে অ্যাটেন্ডেন্সটা
ঠিক আছে।
সব ট্র্যাক করছি, কে
হুম।
ক্লাস করছে কে ক্লাস করছে না, তো
হ্যাঁ হ্যাঁ
আমরা অ্যাটেন্ডেন্সটা নিচ্ছি এবং এটা ম্যানুয়ালি কাউন্ট হচ্ছে। ওকে, তো তুমি
ঠিক আছে।
একটু বলে দিও সবাইকে যে পরের দিন যেন অ্যাটেন্ডেন্সটা ঠিকঠাক দিয়ে তারপরে যেন লিভ হয়।
ওকে স্যার।
ওকে, মানব দাস এখন আবার জয়েন করলো।
এখন জয়েন করি ক্লাসে আছে। কি বলবো?
ঠিক আছে, ওকে, নো প্রবলেম।
ওকে স্যার।